organizers of CNCF Kochi community. We have two more other organizers. They are not here at the moment, like Pravish and Dijesh. They have gone to the AWS reInvent, which is happening in Las Vegas, I think. So let's get started. Iqbal, do you want to give a small introduction of yourself before we start? You're mute.
Yeah. Hi, I'm Mohammed Iqbal, working as a cloud architect at Codage. Yeah. We can interact after the session, right? We can have a network session after the session.
Okay, cool. So let's get started. So here, I hope you guys can see my screen, right? So, all right. 1 second, let me just get that screen ready. Okay. So today's topic, deploy and manage Kafka using strimzi. So I using strimzi and FluxCD. So I believe at least many of you this Kafka or FluxCD or strimzi operator, these terms might be new, but let's see how much we can cover in this session, or later maybe we can do a deep dive session to each of these tools. But consider this session as an intro to get started you with the strimzi operator for deploying and managing Kafka using FluxCD. But if you want any session which is a deep dive to each of these tools, we can arrange that later. Let us know how we can do that in the end of the session. So a small introduction about myself. Currently, I'm working as a DevOps consultant and a developer at TopTal. So I'm also founder of crossmigrate.cloud project, which is completely open source cross cloud migration tool. And also other open source tools are there which I'm maintaining. So I'm an open source contributor too. You can find me in all social media platform at the right. I am Vishnu KS handle. I'm pretty active in LinkedIn. So if you have any queries or any doubts related to anything, like even if that is a job referral or something, just ping me on LinkedIn. So today's session overview. What is Kafka? Sorry. What is Kafka and Streamzi operator? So we will be covering what is Kafka in gist, not in any details, and how Streamzi help us in deploying Kafka to Kubernetes. Then we will see how FluxCD work with the GitOps, and like how FluxCD is doing GitOps and what is GitOps. And at the end, we will also have a demo. So Kafka with the strimzi operator. One more thing, like this session will be quick. It won't be dragged to like 45 minutes or 1 hour, but I will make this session very short and sweet. Don't want to inject too many details to this session, but as I said, later we can have any deep dive session if you guys request. So here, Kafka with the strimzi operator. I believe all of you might be aware of the use cases of Kafka. Some generic use cases are to use Kafka as a message queuing system, buffer for your logging or metric pipeline, and many legacy system. I have seen people use Kafka instead of ESB now as an ESB replacement. So I'm not going to dive any detail of any of these use cases. Rather, we will focus on deployment aspects of Kafka with the strimzi operator. So in gist, Kafka is an OSS distributed event streaming system. And the strimzi operator help us in deploying and managing Kafka cluster on top of Kubernetes. strimzi operator not only help us in deploying and managing just Kafka buckets, it also help us to create topics, usage, mirror maker, Kafka connectors, and other custom resources on Kubernetes. So that's all strimzi can do. Not only that, it can do much more. We'll cover that later. So now I just want to share some insights on what is GitOps and how FluxCD can do that. So FluxCD, it's a project, it's an open source project which was developed by Vworks. So it's a continuous deployment tool which helps in implementing GitOps in Kubernetes environment. So what is GitOps is it's a methodology in which the state of the infrastructure or application is managed as files in version control system. So what that means is that if you have any infrastructure built as code, so you keep that code in a version control system, right? And whenever you want to make some changes to that infrastructure, you make the changes in the code, and that automatically picked up that change automatically picked up and get updated in the actual running infrastructure. It can be your dev environment, pre-prod or stage environment, and can be production environment as well. So no one is going to the console, or no one is ad hocly running like a Terraform or something to create the infrastructure from their laptop or from the console directly. Rather, they just update that code in the Git in your Git repository where you have this infrastructure codes. You just update it there. It will deploy that change. It will update that change in your application infrastructure. So same methodology can be applied for the application configurations also. For example, Kafka configuration or Elastic, if you are managing Elasticsearch, if your platform team is managing Elasticsearch, and if you want to update configurations on the fly to tweak something to increase the JVM configuration or something, you won't do that on the actual service, but instead you will do that in the Git repository where you manage these configuration files. When you update this configuration file, you should have a pipeline. You should have automations in place to um, update that change in configuration to your actual and application environment. So no monkey business. No one is allowed to change anything on the infrastructure or application directly. So that's all about GitOps. So in our case, FluxCD will be running in our KS cluster, monitoring the Git repo for the changes in KS manifest for Kafka resources. So I have a diagram for that. So here, this is a very high level diagram, how Flux is deployed and where it is deployed and how it works. I can explain that from here. So here, this green box is our Kubernetes cluster environment. And when we there's a step called Flux bootstrapping where we install Flux to the Kubernetes cluster. And in that bootstrapping stage, we mention the Git repository where it should be looking for the manifest for Flux to deploy that to Kubernetes cluster. So how it works is Flux will be deployed into a new namespace called Flux system, and that Flux system will be looking to a particular Git repository which we have mentioned during the Flux bootstrapping stage. So in this case, we have this repository here, and Flux will be synchronized with this repository. So here in this repo, we can have Kubernetes manifest, hem chart values, and customizations which are required for Flux. So based on the manifest here, Flux will deploy the applications to your application namespace. So that you can define here, like which manifest or which hem release should be going to which namespace. All that can be mentioned here, and you can create namespace or you can create persistent, volume, secrets, config map, all of them from just update the YAML files here and update the Flux customization YAMLs descriptions, and then Flux will automatically take this change every 1 minute. It will synchronize the manifest and hem release values from here and update the running application. We'll do a rollout updates in the running application. So that's how Flux will do GitOps. So all the operations dev is directly doing to the Git repository. He's not making any changes to the running application directly by running kubectl apply -f or hem release command. Instead, he is prohibited to connect. He's not allowed to connect to the running cluster. Rather, he will just update that to the Git repository. So here, the team can have a workflow as well. So if they want a review process, like they can create a branch, they can branch out from dev, and they can get that hem release or hem values or manifest, whatever application they are, get that reviewed with the other team members, and when they merge that to dev environment, it automatically get deployed to dev environment. So it is branch specific. We'll have dev, pre-prod, and prod depending on the organization and the team, how they work. We can have we can have any number of branches, but each branch will be tied to an environment. That's the only case here. And even you can have different repository for each environment. That's also fine. But a common pattern we have seen is that we will have different branches for each environment. So each branch is tied to one environment. So if you are deploying an application to dev, if you want to do the same deployment to prod or pre-prod, we will need to merge that, like from lower to upper, dev, pre-prod, and prod. So that's all about FluxCD and GitOps. Now let's see a demo. I believe all of this which I mentioned was clear, or else we can have a QA at the end, but we will just continue with the demo for the moment. But even if you have any questions, please put that in the chat. So we will take all this, we will address all the questions after the demo. So let me share. I think. So I have my cluster over here. So it's a EKS cluster, basic EKS cluster, and I have 4 nodes here. I have no deployments anywhere. Like I only have these 4 namespaces here, right? So let me now open my Visual Studio Code. Okay, now as you can see, this is a public repository, strimzi Kafka demo, and this repo is available under CNCF organization repo. It's a public one. I will share the details at the end of the meeting. You guys also can fork, or you can just clone and try things out with this. You can just fork and then try the same thing which I'm explaining right now. So first thing what we need to do is, I have a small readme here. So first thing what we need to do here is the Flux bootstrapping. So here, if you see, first you have to export the GitHub token, your personal access token with the repo scope. You can create that from GitHub console. You just go to your settings, and on the left-hand side, there will be developer tab. Open that, then go to personal access token and select the repo from that. we only need repo scope for the GitHub token. And here Flux Bootstrap GitHub, you can see I have mentioned GitHub. Like if it is GitLab or Bitbucket or any other source version control system, then this will change. You can find that in the Flux documentation. If you are using any other Git, I mean any other source version control systems. And here I have mentioned the like basically this repository, as I mentioned, is in organization CNCF Kochi. So we need to mention the organization name with the dash dash honor flag. And then we have the repository name, strimzi Kafka demo. Then I have mentioned private files. If you have private repository, then you have to mention, if your repository is private, then you have to mention true. Then I have mentioned path clusters demo cluster. So here you can see in this repository, I have created a cluster folder and then a demo cluster folder. So in cases where we have multiple clusters which needs to be synchronized with the same repo, this structure is very useful. So when you are bootstrapping with another Kubernetes cluster, you just need to add a new folder here, cluster slash a new cluster name. So if you go here now, sorry, if you go here now, you will not see anything inside demo cluster. So we have something inside apps.aml. I will come to that. So what I was saying, if you are adding a new cluster with the same, so for example, we are installing Kafka, Elasticsearch, or Prometheus, Grafana, the observability complete stack from this particular repository. And if you want to have all this application in multiple clusters, you can you can synchronize multiple clusters to this repo. That's what I was saying. But let's not go there. So that is a little so I see a message from Neurons Joseph saying that still seeing presentation page.
I'm actually still seeing the presentation number 6. Just wanted to check, is that only for me or?
Can someone confirm please, because I can see that
Okay.
what I'm sharing is Visual Studio Code.
Okay. This may be an issue from my end.
Okay.
Okay. No worries. Sorry to interrupt. No.
No problem. Okay, so now here, as you guys see, so what I was mentioning, like if you want to install same set of application to different clusters, you can do that with the Flux. But that is a little advanced topic which needs to be discussed in detail for a Flux deep dive session. So we will do that later. So here I'm just mentioning the path to the demo cluster. So I'm just copying this command and executing it here. You can see that a series of operations happening here. So this is our Git repository. So I will share that at the end. So you see here, all components are healthy: source controller, notification controller, customized controller, hem controller. So these are the certain controllers which are installed by Flux during the Flux bootstrapping. So these are certain controllers which are being installed and managed by Flux operator. So let's see that here. Now we should have Flux system. Yeah, we have Flux system namespace. And you see hem controller, customized controller, notification controller, and source controller being deployed here. So we will see that in detail on a different session. So now we have Flux installed, and now let me come here. We have an apps.yaml in this cluster path. So what it is mentioned here is say customization kind and names app, namespace Flux system, and kind git repository Flux system /apps. So what this means is it is an instruction for Flux to look into this apps folder and deploy everything what is there. Okay, simple as that. So it is not anything much complex. So here it is mentioning the source reference. So the source reference for Flux is Git repository, and the name is Flux, and the path for the applications in this Git repository will be /apps. Okay, so that's all what we have here in clusters folder. So now we will go to apps folder. That's from where our applications are getting deployed. So here the application is already there, so it should have been deployed already, but let us see if it got deployed or not. We see that a Kafka namespace created, but the item list is empty here. Nothing got created. So for the reason for that is there are ways to handle, but I don't want to do that like this. So let me explain the problem. So first of all, Kafka needs to be deployed at first. I mean, strimzi operator should be deployed at first, and then only we can deploy any resources for Kafka. So here there's a flux command. Let me just, so flux get all the head. So it will get all resources created by Flux in all namespaces. That is dash capital AME. So you see here, there's a problem. Tried and failed. Error no matches for kind Kafka in version kafka.strimzi.io. Because first we need to use we have to install strimzi operator, and then only we can install Kafka kind resources. So here I'm going to comment out Kafka, and then when we deploy, strimzi Kafka will get deployed. So I will just mention the order now. So in the /apps folder, we have Kafka folder, strimzi Kafka folder, customization YAML, and namespace.yaml. So in the namespace, it's a normal namespace Kubernetes manifest, and the name is Kafka, right? And in Kafka, we have definition to deploy Kafka cluster. So replicas 1 of that replication factor, all these are set to very minimum for this demo. And the persistent claim for zookeeper settings, and all this I have mentioned in Kafka cluster.yaml. And then I have a test topic.yaml here. So the topics are also created and managed as a YAML file. And we have customization YAML here. So here we just mention the file names here, which we have the definition for Kafka cluster and topic. So here, this is the file customization.yaml will be the file which will be looked by Flux. So here we have mentioned we need to deploy these resources, Kafka cluster.yaml and test topic.yaml. And in strimzi Kafka, we have Kafka metrics config map.yaml. This is for Prometheus to scrape all these metrics. This is for the node exporter. and then we have strimzi Kafka hem release.yaml. So it is just a simple release file. So values file. Let me see. Yeah, we are not using any custom values. We are just using the default values for the strimzi Kafka operator. The hem release values. We are not having any custom values here. We are only using the default value. So this is a hem release manifest. So when I say hem release manifest, so you might have, there might be people here who have some experience with the hem install, hem release command, right? So this is basically a manifest for Flux to do that. Simple as that. So yeah, and here the hem repository. So we also do hem repo add commands in our CLI, right? So similarly, we need to add the hem repository into a namespace. So here I am adding the repository to our default namespace, and I gave it a name strimzi Kafka repo, and the URL I have mentioned here. So this is something similar to hem repo add command, but this repository, when we do hem repo add command, that repo will be added locally in your laptop, right? So we need this repo to be available in the cluster. So that's why we need this, because Flux is the one who is doing all this deployment. It needs the repo related informations in the cluster or somewhere it can access. But here in this case, it is a cluster which it can access. So here also we have customization.yaml, because when Flux comes into this folder, it will be looking for this YAML file only. And here the definitions for deploying the resources are mentioned here. Okay, so this order is not taken well. Like if you have dependencies with, like if you have a dependency like this needs to be deployed after this, or in the same order. Let's say this hem release only needs to be deployed after this, then you can have a dependency in your Flux configuration. Like here in this hem release descriptor, you can have a depends keyword, and you can mention the name of this resource. That I haven't done in this example, but maybe we will see that on a later session. So that's what we have in strimzi Kafka. And now outside we have a customization.yaml. So that's from where I have removed commented out -Kafka. So here namespaces.yaml, strimzi Kafka, and Kafka. These are the three things which we need to deploy, right? So first we need namespace, and then we need to install strimzi Kafka operator to that namespace. Then only we can install Kafka. So basically, I haven't mentioned the dependency here. So if I have mentioned the depends keywords in this Kafka cluster deployments for strimzi to be available first, then this issue might not have happened. But I don't have that in place at the moment, and it may take some time to test that out. So I'm not doing that at the moment. So what we will do here now is I just commented out Kafka. Okay, so it's the same effect. If you delete this Kafka folder from this repository, it is the same effect, because Flux will only be looking at this customization.yaml file, right? So I'm just commented out Kafka. I'm telling Flux not to install Kafka, just only the namespace and the Kafka operator. So now I'm just committing that to the repository. We can monitor that, monitor it with the Flux get all commands. So it doesn't have any relation to the synchronization or anything. When we are running this command, it is not gonna synchronize at that instance. Okay, it is just a command for you to understand what is happening with the Flux. So it is still on the same revision. Let's wait for that for the next synchronization. So now it fetched a new synchronization. So now let's see. You can see strimzi cluster operator is being deployed to our Kafka namespace. So now it is running and it's available. So now what we will do, we will also uncomment this Kafka from the customization.yaml for Flux to install Kafka resources. What it will do is it will install. Okay, I will just commit and then explain. Install Kafka. Okay, so what it will do is if you come here and see Kafka here, so it will create cluster and topic. So when I say cluster, what all resources we are expecting to be created is it will install Kafka with version 3.2.0 with replica as 1, and we will have only uh, internal services, one without TLS and one with TLS. You can have users created for this, and you can enable MTLS authentication for the clients, like whichever client, if you are sending data to Kafka, and if you like if some producers are sending data to Kafka, and if you want some authentication in between that, you can enable MTLS with the users. You can create a user also user resource also with the Kafka. You just need to create another YAML file and create the resource of type Kafka user. So that examples are available in strimzi official strimzi documentation. And here offset topic replication factor, everything I have given some minimum value. Then we have zookeeper configuration. We only have one zookeeper. And the persistent claim for zookeeper, and here we had persistent claim for storage for the Kafka broker. So JMS Prometheus exporter configurations we have mentioned here. Kafka metrics. So the user, as you can see, when we are installing Kafka cluster, we are also installing topic operator and user operator. We are using topic operator here. I will explain that. And we are not using user operator. That's what I was mentioning. If you want to create a user for client, producer, and subscriber to have some authentication between the communication happening to Kafka and from Kafka, you can use that with this user operator. Okay, and here we have topic and topic name. We have given test topic, namespace Kafka, and cluster name we have mentioned here. So we can have multiple clusters, multiple topics, multiple users, and things like that here. And here partition also I have given one, and replica also one, and all the configurations which are related to the Kafka can also be given here. So another one benefit I missed to put that in the slide is the cruise control. Cruise control is an open source project by LinkedIn. There is a tremendous things which we need to do when we have to rebalance a Kafka cluster. So during events of massive load, some of the partitions might be taking huge traffic, and some of them might be not taking that much traffic. So in such events, or even if we are adding a new broker and new partition, then we want to balance the traffic balance the data between the partitions and replicas. So that was being done manually in the past, but with cruise control that can be automated. And this strimzi operator have native support for cruise control. So that's pretty good, and it saves a lot of time on our day-to-day operations. So now let's go back here and see all these resources have been created. Kafka cluster is there, and Kafka exporter, that is a metric exporter, and Zookeeper also is there, and everything is there as expected. Okay. All right. So now what we will do, now we will just try to publish and subscribe to this Kafka cluster. So one more thing before we go there, I just want to show you. So here in Lens, if you're using Lens ID, so here you see all these events. So even you can avoid using Flux get all -a command, which I was using here to describe all the Flux deployments. Here you can use events to do that. You can see that with events. So chart releases, Kafka operator, that all we can see from here. ID. This is very pretty cool ID, which I use in day-to-day operations. I use this ID so much. So yeah. So now let's come back here. I'll open another one as well. So here. readme.md. So this command, what it will do is a basic kubectl run command. So it will run a Kafka producer with this image provided by strimzi and attach that to the test topic in that particular cluster, which you can Kafka cluster, Kafka bootstrap 909. So that is the service name. Here, if you come here in the network services, you will see the service endpoints. This one, Kafka cluster, Kafka bootstrap. So the service name will be by default with the Kafka cluster is our cluster name, and Kafka bootstrap is the kind of default name which is provided by strimzi. So this is kind of concatenated. Let's give it a minute to pull the image. And this is a console producer. So it will be subscribing to that particular topic. This kubectl run will be subscribing to the topic. I opened that in a differential. Okay, now let's say hello. We can see if okay. Okay, it's not started. Okay, now it is started. So the message is here. Hello, CNC Koji. So now it should come instantaneously. Right, yeah. So our topics are working fine. So this is the bare minimum setup which just need to get started. But for going to production, you will need to have fine tune your settings for each topic, and you will need to have more partitions and more replicas and more brokers, zookeepers, and a different dedicated node group for this Kafka setup. And yeah, and also it natively support like you can mention like if you have a highly available setup, if your nodes are spread across different availability zone, then you can have each of your Kafka broker in those availability zone as well. That all things are natively supported by strimzi operator. So do have a check on their official documentation for more details on how you can operate your Kafka cluster seamlessly with strimzi operator. I hope that is going to be very uh, it's going to unload a lot of pain as a platform engineer. Is going to unload a lot of pain managing Kafka with its day-to operations. So that's all for today, folks. Let me know if you have any questions in the chat. Yeah, I see the question from Rakesh is like similar to how we have created the Kafka cluster and topic. You just need to create a new YAML file and describe, just define your cruise control settings out there, and it will automatically get deployed into your cluster, and it will do the cluster rebalancing when you are adding a new broker or when there is a massive load for on your Kafka cluster. It will do all the rebalancing for you natively. So the one advantage with the FluxCD, I mean, you can go and start deploying things with the hem install, hem release commands like strimzi and Kafka can be deployed with the hem charts as well. But one beautiful thing with this GitOps is you are not directly touching or hitting the cluster. You're not modifying anything on the cluster directly. You have the current configuration, what you have applied on somewhere, Git repo, where everyone can see and access. So I always prefer to use FluxCD or Argo CD, some CD tools tied up with your Kubernetes cluster, so that you don't go to cluster and manually change the configurations of applications or the nodes. So yeah. I believe Flux supports it. What else you can do is also you can reduce the time for the synchronization. Like currently it is kind of 1 minute, and it's not better to reduce because like each time when it do a request, it is going to hit the Git repository, right? So we shouldn't be DDoSing. Like if you are running Git in your on-prem setup, if you have Bitbucket hosted or GitLab hosted in your on-prem setup, then we will be DDoSing in our own environment. It's not too much, but still, there will be many applications, right? Manual sync, yes. Also, please mention what you're expecting to see in the next session. And we also welcome speakers from the community. Like if any of you would like to do a session with the CNCF community Kochi to talk about any tools or specific use cases which you have done in your organization, let's get in touch and let's do that in coming weeks. If no more further questions, let's wrap up today's session. Once again, thanks for joining us, everyone. Let's meet in the next.
Uh, I think we can wrap up by taking a photo. At least
Okay. Yeah.
turn on your camera so that we can take a photo. Hi, Andu. Hi, Nero.
I'm-
Hi, Ajish. Hi, Abhi. Yes. Hi, Rakesh. Hi, Nidhi. Yeah. Mm, yeah. I think we can. Okay. Any more? Any more, guys? Right. So, we can show like this, right?
Yeah.
Yeah. Vishnu, can you please take a photo?
Yeah. Sure.
So 1, 2, 3. Yeah.
1 second.
Yeah.
Yes. Done.
Yeah.
Yeah. Cool. Done.
Done. Yeah.
Yeah.
Okay, Flux. Thanks for joining. And uh, we also welcome for our future events. Yeah. I think we can wind up, right?
Yeah. All right. Iqbal then. So let's catch up in the next events and let us know the feedback in our WhatsApp group. And also let us know if any of you would like to do a session to share your experience with some tools or technologies or some solutions. Let us know. Like we appreciate you guys also being involved and being part of the community. So yeah, that being said, let's wrap up for today and let's join in the next event. Thanks guys for joining. Bye.